What if daylight vanished before sunset, and only hours later, the same sky erupted with pieces of a comet? On August 12, 2026, the moon's shadow will race across part of Earth, briefly hiding the sun. Then, after darkness returns naturally, the Perseid meteor shower will approach its peak beneath an almost perfectly moonless sky. Two spectacular celestial events. One extraordinary day. But who will actually see them? And how can you witness them safely? Most days pass without changing how we think about the sky. The sun rises, crosses overhead, and disappears below the horizon. Stars emerge, but city lights hide most of them. August 12th will be different. During the day, a total solar eclipse will cross the northern hemisphere. That night, Earth will continue moving through a river of ancient comet debris, creating the Perseid meteor shower. These events are not physically connected. The eclipse is produced by the alignment of the Sun, Moon, and Earth. The meteors come from particles left behind by Comet Swift-Tuttle. Their appearance on the same date is a remarkable coincidence. And the new moon responsible for the eclipse also removes moonlight from the night sky, creating excellent conditions for watching the meteors. The story begins approximately 150 million kilometers away, with sunlight traveling toward Earth. A total solar eclipse occurs when the moon passes directly between Earth and the sun. The moon is approximately 400 times smaller than the sun, but it is also roughly 400 times closer to us. From Earth, that coincidence makes the two objects appear almost equal in size. As the moon moves into position, it casts a narrow central shadow called the umbra. Anyone standing inside that shadow's path will see the sun's bright surface become completely covered. Daylight fades. Temperatures can fall. The horizon may glow like a sunset in every direction. Bright planets and stars can emerge in what should be daytime. Finally, the sun's corona, its ghostly outer atmosphere, appears around the black silhouette of the moon. For most locations inside the 2026 path, totality will last less than 2 minutes. Near the center of the path, it may continue slightly longer, but still for less than 2.5 minutes. Months of planning will lead to an experience measured in seconds. The moon's shadow will begin its journey in the Arctic region, crossing a remote section of northern Russia before moving over Greenland and the North Atlantic. It will then pass across western Iceland, including Reykjavik, before reaching northern Spain. A tiny corner of Portugal will also enter the path of totality. In Spain, the timing makes the spectacle especially dramatic. The eclipsed sun will hang low in the evening sky, close to the horizon. But that beauty creates a challenge. Mountains, buildings, trees, or low clouds could block the view. People outside this narrow path will not see the sun disappear completely. Much of Europe, including the United Kingdom, will experience a partial solar eclipse. Most of Canada and sections of the northern United States from Alaska toward North Carolina will also see part of the sun covered. This distinction matters. A 99% eclipse is still not the same as totality. Even a tiny exposed section of the sun remains intensely bright. And that brings us to the most important part of this entire video. Never look directly at the partial eclipse without suitable eye protection. Regular sunglasses are not safe, regardless of how dark they appear. Use certified eclipse glasses or a proper handheld solar viewer. The American Astronomical Society recommends viewers that meet the ISO 123.2 safety standard. Never look through binoculars, a telescope, or a camera without an appropriate solar filter securely attached to the front of the optics. These devices concentrate sunlight and can cause severe eye injury almost instantly. Only people standing inside the path of totality may briefly view the sun without eclipse glasses, and only while its bright face is completely covered. The glasses must go back on as soon as sunlight begins to reappear. For everyone seeing a partial eclipse, eye protection must remain in place throughout the event. Then the moon's shadow moves away. Daylight returns. Birds resume their activity. The temperature rises again, but the sky's performance is not finished. Hours after the eclipse, Earth will rotate into natural darkness. With the moon positioned close to the sun, almost no moonlight will wash out the stars. Above us, Earth will be traveling through dust released by Comet 109P Swift-Tuttle. Swift-Tuttle is enormous by comet standards, with a nucleus estimated to be around 26 kilometers wide. It travels around the sun approximately once every 133 years, leaving particles scattered along its orbit. Every August, Earth crosses this debris trail. Most of those particles are no larger than grains of sand. Yet they strike our atmosphere at approximately 59 kilometers per second. At that speed, the air in front of each particle becomes intensely heated. The meteor itself and surrounding atmospheric gases glow, producing a streak of light that may last only a fraction of a second. The object is not a star, and it is not truly falling toward us from deep space at that moment. It is a tiny piece of ancient comet material ending its journey in Earth's atmosphere. The Perseids received their name because their trails appear to originate near the constellation Perseus. That point is called the radiant. However, you do not need to stare directly at Perseus. Meteors can appear anywhere across the sky, and those farther from the radiant often produce longer, more dramatic trails. The Perseids are famous for being fast, bright, and capable of producing fireballs, exceptionally luminous meteors that can rival planets in brightness. NASA meteor expert Bill Cook has described the Perseids as the annual meteor shower's fireball champion. Under dark skies in 2026, NASA estimates that observers may see approximately 25 Perseid meteors per hour. Actual numbers will vary with location, clouds, light pollution, viewing time, and how much of the sky is visible. The International Meteor Organization places maximum activity on August 13th, meaning the most productive viewing period is expected during the night of August 12th into the early morning of August 13th. The later you remain outside, the higher the radiant climbs and the better the viewing conditions generally become. You will not need a telescope. In fact, a telescope shows such a narrow section of the sky that it can make meteor watching more difficult. Instead, travel away from strong city lights and find a safe location with a wide, unobstructed view. Lie back, allow your eyes approximately 20 to 30 minutes to adjust to the darkness, and avoid looking at bright phone screens. Face toward the darkest section of sky rather than directly toward nearby lights. Give yourself at least an hour, because meteors rarely arrive on command. Several may appear close together, followed by long, quiet gaps. And check the weather forecast. No amount of astronomical planning can see through thick clouds. If you could witness only one event, which would you choose? Would you stand inside the moon's shadow and watch the sun disappear, or spend the night beneath a moonless sky waiting for a Perseid fireball? Write Eclipse or meteors in the comments, and tell us where you would watch from. For most of human history, eclipses and meteors arrived without scientific warning. A darkened sun could inspire fear. Meteors might be interpreted as messages, omens, or signs that something had changed in the heavens. Today, orbital calculations allow astronomers to predict the path of an eclipse years in advance. Scientists can trace the Perseids back to their parent comet and estimate when Earth will cross the densest part of its debris stream. Understanding these events has not made them less beautiful. If anything, knowledge makes them more extraordinary. During the eclipse, you are watching a shadow travel across a rotating planet. During the meteor shower, you are watching Earth collide with material left behind by a comet over many journeys around the sun. One event reveals the precision of celestial alignment. The other exposes the debris-filled path our planet follows through space. On August 12th, the sun will not truly vanish, and the stars will not actually fall. Yet for a few unforgettable moments, both illusions will feel real. The moon will remind us that darkness can arrive in daylight. The Perseids will remind us that apparently empty space is filled with fragments of ancient worlds. All we have to do is prepare carefully, find the right place, and look up. Follow SciSpark on TikTok and Facebook, and subscribe on YouTube for more journeys through science, space, and the universe. With that said, thanks for watching, and until next time.